Yeah, dear students, good evening. I'm going to explain the most important questions. The expected questions, 4 marks they may ask this. So today I'm going to explain. See the first the possibility question integral root of tan x plus root of cot x dx. I can use this one. You can see this integral root of tan x plus root of cot x dx. So these are one of the problem. So this problem they may ask with limits, without limits, two options. So the doing the procedure will be same. They may ask with limits or without limits. No issue. They may ask with limits or without limits. They can ask with limits or without limits. Right, they can ask with limits or without limits, they can ask. See in this problem, so because sometimes they are asking limit 0 to pi by 4, sometimes 0 to pi by 2, 0 to pi by 2. So this is important problem. So doing the procedure will be same, without limits or with limits. So see in this problem, when they are given like this, I can write 0 to pi by 2. Root tan x means I can write root sin x by root cos x plus root cos x by root sin x dx. Just you write cot x cos x by sin x, root cos x by root sin x. Now this one integral 0 to pi by 2. Just take LCM, this root sin x, it will come sin x plus cos x by root sin x cos x. Correct, it will come root sin x cos x dx. It comes like 0 to pi. This is 0 to pi by 2. The limitations. Sometimes they may give 0 to pi by 4 also without limits also. Doing the process will be same. 0 to pi by 2. Limits. Now we have to simplify this problem. What I will do now? Here. I can, this is sin x plus cos x. I can consider sin x minus cos x is equal to t. You take sin x minus cos x is equal to t. Sir, why you have to take? You see integral sin x will be minus cos x. Cos x will be sin x. If you take sin x minus cos x is equal to t, then I can eliminate this. This will become d. You can see now. Sin x minus cos x is equal to t. How to do this? How to take the substitution? Put sin x minus cos x is equal to t. How to consider the substitution? That is important. How to get the substitution? Because you see integral sin x minus cos x, integral cos x sin x. This will be your substitution. If you differentiate this, derivative of sin x cos x, derivative of cos x minus sin x, it will be cos x plus sin x dx is equal to dt. See everything, this will become as dt, right? This you see the numerator along with this you got dt. When I am transferring dt, I should eliminate this also in terms of dt. Limits also should change. Even I will change the limits also. When x equal to 0, you can see when x equal to 0, this is the x values. So what about the t here? I can write t equal to sin 0 minus cos 0. Sin 0 0, cos 0 is 1. It will come t equal to 0 minus 1. It will be minus 1. Correct? This will be sin 0 minus cos 0. Sin 0 minus cos 0. Cos 0 is 1. It comes t equal to, when x equal to 0, implies t equal to minus 1. Similarly, when x is equal to pi by 2, when x equal to pi by 2, then t equal to sin pi by 2, 1 cos pi by 2, it will be 1. Limits it will convert it to minus 1 to 1. I have done the limits minus 1 to 1. At the same time, you think, well, what about sin x cos x? You take this expression, just you take this expression squaring on both sides. If you do squaring on both sides, sin square x plus cos square x minus 2 sin x cos x minus 2 sin x cos x is equal to t square. Correct? Then this is 1. You know that this is 1. 1 minus 2 sin x cos x is equal to t square. 1 minus 2 sin x cos x is equal to t square. Correct? We can write this. I got 1 minus cos is equal to t square again, right? Now you can say I want sin x cos x value. So if you want sin x cos x value, just observe here. This I can write from this 1 minus t square by 2 equal to sin x cos x. Now I can write limits also. We change minus 1 to 1, correct? Minus 1 to 1. I have taken the limits when 0, it is minus 1 to 1. This is dt I have written. So 1 by root of sin x cos x 1 minus t square by 2 inside the root. I can write 1 minus t square by, because inside the root I have taken this one, root of 1 minus t square by 2 dt. So this will become root to 2 into minus 1 to 1, 1 by root of 1 minus t square dt. Correct? You observe the problem is important problem. Just I am doing this. They have given root tan x plus root cot x. Root sin x by root cos x plus root cos x by root sin x. Take LCM. We can simplify like this. Take substitution sin x minus cos x is equal to t. Differentiate this. Then substitute the limits x values, find t values. Then squaring on both sides. Then sin x cos x is equal to, you will get 1 minus t square by 2. Substitute here. This is, 1 by root of a square minus x square, sin inverse t. 1 by 1 minus t, this is sin inverse t. So I can find now sin inverse t. Correct? You will get, this is root to 2. You will get root to 2 into sin, root to 2 into sin inverse, you get sin inverse t. Sin inverse t limits minus 1 to 1. Limits minus 1 to, now you can apply the limits minus 1 to 1. So you will get root to 2 into, apply sin inverse of 1, you will get minus sin inverse of minus 1. Minus 1. Just if you apply the limits, you see the answer here. You will get the final answer. It comes root to 2 into sin inverse 1 pi by 2. Sin inverse of minus pi by 2. So plus pi by 2, right? Otherwise minus of minus plus 1, sin inverse 1 pi by 2. It comes root to 2 into pi. So your answer is root 2 pi. Root 2 pi is your answer. Pi by 2 plus 2 pi by 2. Root 2 pi is your answer. The model is important. This problem they may ask with limits, without limits. Sometimes they may ask limit 0 to pi by 4. If they ask 0 to pi by 4, the limits it will change minus 1 to 0. Depends. But this model is important. Please learn this. I am expecting this question, maximum possible question. You can try to solve that problem. That's the most important problem. Right. Look at the next problem now. It's clear. I hope you understood this. Still, if I need doubt, please ask me in the chat box. I can repeat the problem. No doubt in that I can repeat the problem if you have doubt. If you have doubt, I can repeat the problem. Okay. Now you can see now. Now I am discussing another one now. Right. So the next problem. Integral 0 to pi x dx by integral 0 to pi x dx. They are asking x dx by the given a square cos square x plus b square sin square x. X dx by a square cos square x plus b square sin square x. This is the problem. B square sin square x. X it is a square cos square x plus b square sin square x. So whenever cos square term, if you see cos square or sin square, whenever you look into the problem cos square, always secondary cos square x common. And also, whenever you see in the x in the numerator, whenever you see x in the numerator, preferably you can do P3 property, integral, P4, integral 0 to a f of x dx is equal to 0 to a f of a minus x dx. Preferably you can use this. If you see whenever x in the numerator, use this property. 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now here, you can consider I is equal to, you can let I is equal to this problem, apply the same property, you will get integral 0, because I can eliminate x. If I apply this, this will become now pi minus x by a square into cos of pi minus x. You replace cos of pi minus x whole square plus b square into sine of pi minus x whole square. This one, I can write this dx. What is cos pi minus x minus cos x? This is sine pi minus sine x square. If you square it, same thing it comes here. Remember, cos of pi minus x, it will be minus cos x. Minus cos x. Sine of pi minus x, it will be sine x. You remember that? These two values you remember. This is minus cos, you remember these two values. Now you can substitute here 0 to pi. This will become pi minus x by, same thing, it become square is there, minus cos x whole square, a square cos square x plus b square sin square x dx. Now we can split pi minus x. Can you split now this one? I hope you understood here, right? This I can write integral 0 to pi. This is I can write pi by a square cos square x plus b square sin square x dx minus integral 0 to pi x by a square cos square x plus b square sin square x dx. So this is given problem. I can replace with I. Left side anyhow we have I is here. Left side we have I. I is equal to pi, I can take it outside 0, pi into 0 to pi 1 by, I can write this one, a square cos square x, a square cos square x plus b square sin square x, a square b square sin square x dx minus psi. I can write minus psi. Thus you can take it minus psi here. If you take minus psi, this one you can see now what I will do now. Transfer minus psi this side, I plus psi. Pi into 0 to pi. Whenever you take cos square x common. If you take cos square x common, it will become 1 by cos square x into, it will become a square. Even I can take it b square cos square x, so no problem, a square plus I can write this one b square sin square x by cos square x. I have taken common, right? When I have taken common, this will become 2y pi into, you can see now, 0 to pi. This will become secant, this is cos square x, you have taken common. This will become secant square x by, this will become a square plus b square tan square x, b square tan square x dx. Still if you want to clarification, I can take b square also common. Then I can take tan x is equal to t, because we want like a square plus t square form. You take b square also common. 2y equal, you take b square common, pi by b square. I have taken common here, pi by b square 0 to pi. Plus I have taken b square common. This will become secant square x by, I have taken b square common, a by b whole square plus tan square x dx. You take put tan x is equal to t. Now the substitution. Put tan x is equal to t. You take tan x is equal to t. When you have taken tan x is equal to t, secant square x dx is equal to dt. The numerator will become dt. Now you can see I have taken tan x is equal to t. Even I can change the limits also. When I have taken here tan x is equal to t, I just have taken tan x is equal to t. So when I have taken tan x is equal to t, you should have substitute the limits also I can change here. Or I can also see here. In this case I can also write this one 0 to pi means When I have taken tan x is equal to tan 0, 0, tan 1 it is 0, 0 to 0. What I will do, before doing that, I can change the equation. This is what I will do now. Before doing this, I can write again, replace x with pi minus x. Same function it comes. If I do, before doing this, what I will do here, before the substitution here, what I will do now in this function, I can write, this function is here. If replace x with pi minus x, so you can take f of x is equal to secant square x by, just see that to apply the property, f of x is equal to, I can write secant square x by a by b whole square plus tan square x. If raise f of pi minus x, secant of pi minus x, you will get minus secant square is the same thing, it comes secant square x by a by b whole square, tan of pi minus x minus tan x whole square, same thing it comes. So this will become f of x. Understood that? So again I will repeat this, replace x with pi minus x, secant of pi minus x will be minus pi minus secant x whole square, secant square x it comes. If we replace that, even tan of pi minus x minus tan x, it comes minus tan x, correct? This is tan square x. If we replace pi minus x, tan pi minus x minus tan x whole square, it will be tan square x. Same thing it comes, this is tan square x. That means function no change. Since function no change, we have the property, I can write, using the property I can write, this is pi by p square into 2 into 0 to pi by 2, pi by 2, I can write secant square x by, because there is the property p6, using property p6, this I can write 2 into half of this pi by 2 secant square x by a by b whole square, a by b whole square plus tan square x dx. Now you take substitution, tan x is equal to t. You got this side here, the 2y we have, I can eliminate 2, 2 I can eliminate, I will get pi is equal to pi by p square, 0 to pi by 2. You have taken tan x is equal to t. You take tan x is equal to t. When I have taken tan x is equal to t, then secant square x dx is equal to dt. The limits also will change now. See here, I got like this. See dx dt, the limits when x is equal to 0. So t equal to 0. When x is equal to pi by 2, t equal to tan pi by 2 infinity. Correct? The limits will come infinity. So the problem will become now, after changing that, it will become 0 to infinity, 1 by, because secant square is dx will be dt, 1 by a by b whole square plus t square dt. But we know that this is like a square plus t, a square plus x square form. This is a by b whole square. Just you observe here. This is a by b whole square plus t square. We know that a square plus 1 by a square plus x square form. 0 to infinity. So I can write which is equal to pi by b square. So if you write the formula 1 by a, so 1 by a means it will 1 by a by b. Correct? 1 by a by b. Tan inverse of t by a by b. It comes limit 0 to infinity. I can apply here. Limits 0 to infinity. 0 to infinity. Now this I can write. Now when I am simplifying here, this b square and b I can cancel. You would get pi by ab. Pi ab. Apply tan inverse. This will in the place of t infinity. Tan inverse infinity. If I apply this one minus tan inverse 0. I will get tan inverse 0. So it comes now pi by ab. Tan inverse will be pi by 2 minus tan inverse 0, 0. Answer will be pi square by 2ab. That is the required answer. This is pi square by 2ab. The problem is important. Try to understand this. If you are doubt, please ask me. I can explain again. This is the most important one. Like your answer is pi square by 2ab. Is it clear? Should I repeat this? Check that. If you want to repeat, I can repeat this. Is it clear? After the most important problem, I will discuss one more important problem I am going to discuss now. Is it clear about that problem? Another important problem I am going to explain, around 6 to 7 problems. I hope you understood this. Should I repeat this problem? Clear? Then good. I can do the next problem now. See, the next also most important model. Many people, they may confuse when they are doing this problem. Just observe this problem. Integral 0 to pi, integral 0 to pi, x by 1 plus sine alpha, 1 plus sine alpha sine x dx. This is x by 1 plus sine alpha, this is alpha, sine alpha sine x dx, this is x dx. Now this is the important problem. Now see, in this problem, but the formula doing problem is simple. You should think. I told you, whenever I suggested you, whenever you see x in the numerator, apply this property. 0 to a f of x dx equal to 0 to a f of a minus x dx. Just you apply this property, f of a minus x dx. Here also consider the problem let I is equal to. You take let I is equal to this problem. Consider I is equal to. Let I is equal to, you can consider. Correct? Because I can write this one. This is integral. Correct? They are given this is integral. So I can consider here let I is equal to. I is equal to. If we replace 0 to pi, replace x with pi minus x by 1 plus sine alpha, because here I can simplify this, then I can write, after applying this one, I can sine alpha sine of pi minus x dx. So this will become, again you can see 0 to pi minus x by, this is x, this is 1 plus sine alpha, sine 180 minus x, sine x only. It will be sine x dx. I have taken I is equal to. The concept of I can split this. I can write pi into 0 to pi 1 by 1 plus sine alpha sine x dx minus 0 to pi x by 1 plus sine alpha sine x dx. But we know that this is I can transfer this side. That is I can transfer this side. Now I can write. So what I will do now, I can see here left side we have I is equal to pi into 0 to pi 1 by 1 plus sine alpha sine x dx minus I you transfer this side, it comes 2I. You will get 2I is equal to pi into 0 to pi 1 by 1 plus sine alpha sine x. We get like this, sine alpha sine x dx, sine alpha sine x dx. Now in this problem, what I will do now, I can make it here, the change here. This is important here, sine alpha sine x. The substitution here, this is important. What I am going to do the substitution, you can see now. The most important one. The place of sine x, first I am going to do the changes. In the place of sine x, I can consider sine x means I am going to substitute. We have sine x in terms of tan. I have 2 tan x by 2 by 1 plus tan square x by 2. Just I have taken, consider sine x equal to 2 tan x by 2 by 1 plus tan square x by 2. This is 1 plus tan square x by 2. Replace sin x 1 plus tan square x by 2. I can get this 2, this is side 2i only, pi into 0 to pi 1 by 1 plus sin alpha into 2 tan x by 2 by 1 plus tan square x by 2 dx. Just I have written sin x, I replaced with 2 tan x by 2 by 1 plus tan square x by 2. Just you can take it LCM here. Just you take LCM here. This will become now pi into 0 to pi. It will go 1 plus tan square x by 2 by, this will become, I can write 1 plus tan square x by 2 plus 2 sin alpha tan x by 2 dx. But we will get like this. Now here 1 plus tan square x by 2 get secant square x by 2. But we know that 1 plus tan square x by 2 will be secant square x by 2. Next up you write that. Replace 1 plus tan square x by 2 secant square x by 2. You replace that. Now I am going to simplify the problem. So what I am doing now, very simple I am doing now. Here I will take tan x by 2 is equal to t. You consider tan x by 2, put tan x by 2 is equal to t. You take tan x by 2 is equal to t. Tan x by 2 is equal to t. What is the derivative of this? You will write secant square x by 2 into 1 by 2 dx is equal to dt. So I will write secant square x by 2 dx is equal to 2 dt. So this numerator, this will become 2 dt. That will become 2 dt. I can write. Limits also I can change. At the same time I can change the limits. You can think about the limits. What can I do here? When x is equal to 0 to x equal to pi. You can think when x equal to 0. So t equal to tan 0, 0. When x is equal to pi, t equal to tan pi by 2 infinity. Correct? This is x values. The corresponding t values I have taken. Corresponding t values. X equal to 0. This is x equal to pi, corresponding t equal to infinity. I can write now pi into, after changing all this, this will become 0 to infinity. This is 2 dt. I will get right. 2, it comes 2 dt. I written 0 to infinity. So when I have taken 0 to infinity, I will come this. So this side we have 2y is equal to, 2y is equal to, it will be 2 dt by 1 plus t square plus 2, this is t, I have taken this as t, 2t sin alpha it comes. Correct, 2y is equal to this after doing the changes. Correct. Now you can see 2y is equal to, I can eliminate this 2. You can see now this is 2, this 2 and this 2 can eliminate. So I is equal to, this is 2i is equal to, right? Correct. This is 2i is equal to eliminate, I is equal to pi into 0 to infinity. You observe here 1 by, this is nothing but 1 plus, what I will do now, our convenient 2t sin alpha. So what I will do this one, I can write this expression cos square alpha plus sin square alpha. 1 means I can write cos square alpha sin square alpha plus t square plus 2t sin alpha. This is dt. Only in the place of 1, take cos square alpha plus sin square alpha. Now you can observe here. If you observe this term, you see this is a plus b whole square form. I can write this one, t plus sin alpha whole square, or sin alpha plus t whole square I can write. You can see this one, I can understood now that one. I can write now, this is pi into 0 to infinity, I get 1 by cos alpha whole square plus, you can observe this one, sin alpha plus t whole square. How? Check that, a square plus b square plus 2ab. We got this. But we know that integral 1 by a square plus x square dx, if it is like this, 1 by a square plus x square dx, his answer is 1 by a tan inverse of x by a plus c will be there. So we know this is the formula. In the place of a we have cos alpha. It is a constant. You follow that. If you follow that, I can write this one pi into 1 by m is pi 1 by cos alpha. Cos alpha I can write. I am doing the problem now. Cos alpha 1 by tan inverse of x means sin alpha plus t. Sin alpha plus t by a means cos alpha. Cos alpha like correct. Limits I can write. Applying the limits 0 to infinity. Applying the 0 to infinity. This inside like this. Correct. Now you can see that final answer I am going to simplify now. Replacing the values. Correct. Just you can apply the values, you can simplify. You will get the final answer right. Because you will get tan inverse of 1 by cos alpha, tan inverse of t sin alpha plus t by cos alpha. In the place of if apply infinity, this will be pi by cos alpha. Pi by cos alpha. Apply upper limit, infinity, tan inverse infinity. How do you get tan inverse infinity? You can check that this is t in the place of t infinity, everything infinity. Tan inverse infinity minus tan inverse. Apply 0 here, the place of the 0. Sin alpha by cos alpha. It will be tan alpha. It comes like this. So tan inverse infinity will be pi by 2. We get tan inverse infinity will be pi by 2. I can write now the final answer pi by cos alpha. This will be pi by 2. Tan inverse of tan alpha is alpha. So this is our final answer. This model was important. Just try to observe the logic. You should practice this question frequently. You should practice. Otherwise difficult to understand. Practice this problem again and again. You should practice. That is important. You practice this problem. This is model also important. Now here, using partial fractions, I am going to explain one or two problems that also you can learn. See that another problem. Integral x square plus x plus 1. Integral x square plus x plus 1. After this problem, I hope you understood this. See the next problem. Integral x square plus x plus, we can see that I am talking about this one. Integral x square plus x plus 1 by x square plus x square plus x into x plus 2 dx. This x plus 2 dx. X square plus x plus 1. This is not n. Consider x square plus x plus 1 by x square plus x plus 2 dx. So here the most important one, to split partial fractions. That is important here. Here I will explain how to split the partial fractions. Then writing the integration will be easy only. So I will consider now. This one I can write. You can consider, let x square plus x plus 1 by x plus 2 into x square plus x equal, I can write linear factor, quadratic factor, x square plus x. Correct. Now you can see this, I can write this one. What I will do here, easily we can write this one as, what I will do, this is a, since linear, since it's quadratic, it will be, since is it here linear, it will be constant. Since the denominator quadratic, it will be linear, bx plus c. So you should find ABC values. If you find ABC, then easy to solve the problem. Now I can write this side. If you take LCM, this will become a into x square plus x plus bx plus c into x plus 2 by, you will get x plus 2 into x square plus x. Comparing both sides, I can equate the numerators. So you will get now x square, just you observe here, x square plus x plus 1 equal to a into x square plus x. These are all x only, don't consider as n. X square plus x plus bx plus c into x plus 2. X plus 2. Now how to find the values of ABC? To find the values of AB is always under a linear factor. To find a, always x is equal to x plus 2 equal to 0, take it in the rough work, x plus 2 equal to 0, x equal to minus 2. If we consider x equal to minus 2, b and c I can eliminate. See, x equal to minus 2, b and c I can eliminate. You can consider x equal to minus 2. Put x equal to minus 2. So let it be, this is equation 1. You take x equal to minus 2 in 1. You can, that is equation 1, you can consider. This is equation 1. I written, let it be, this is equation 1. Consider x equal to minus 2 in 1. If we substitute minus 2 in 1, both the sides, you will get this side, minus 2 whole square. 4 minus 2 plus 1, a into, you will get 4 minus 2. This side will be 0 because minus 2 plus 2 will be 0. So you will get this one. 3 is equal to, you will get a 2a, right? A is equal to, you will get 3 by 5, you can write. This is, you can see here, this is 3 is equal to, it comes 2a. So then what is a value? A value will be, you can see here what I have written here. So this one, I have written x equal to minus 3 I have taken, right? This is x square plus x. Oh, you can see x minus 2 whole square, sorry. X square plus x you have taken. Correct. Oh, you can substitute the values here. If you substitute the values, the problem is given x square plus 2x square. Oh, this one, the problem you can see here. The x square plus x square plus 2, this one. Here I can write this problem here when I have taken like this, the factors. I think small change I will do this problem. This is x square plus 1. My mistake, x square plus x. This is x square plus 1. X square plus 1. This is x square plus 1. Take x square plus 1 and x plus 2. There is no change. X square plus 1. This is the given. By mistake I have taken that one. I changed that one. Take x plus 2, x square plus 1. X square plus 1, x square plus 1. This is also x square plus 1. You will get x square plus 1. So this is the model, x square plus 1. If I substitute x square plus 1, so it comes here, this one. X square plus 1, 4 plus 1. You will get 5a. A is equal to 3 by 5 it comes. This is the value, a is equal to 3 by 5. Just you do the small change I have done. A is equal to 3 by 5. Now, to find b and c. To find b and c. But we know a value. Suppose if I put here as x equal to 0, I can eliminate C clearly. When x equal to 0, a and b I can eliminate. Directly I can find c. Put x equal to 0 in 1. Put x equal to 0 in 1. If we consider x equal to 0 in 1, x equal to 0 in 1, x equal to right side you will get 0 plus 0 plus 1. It comes a also will get a into, you will get 0. You can see that. If we substitute a equal to 0 here, a into 0 plus 1, this will be b into 0 plus c. It comes into 0 plus 2. 0 plus 2 it comes, right. Now you will get the value 1 is equal to a plus 2c. You got 1 is equal to a plus 2c. But we know a value 3 by 5. 1 minus a equal to 2c. So 1 minus 3 by 5 is equal to 2c. Then you will get 2 by 5 is equal to 2c, right? 5 minus 3. C is equal to 1 by 5. So I can get C is equal to 1 by 5. So the C value it comes. Now similarly, you should find, like I got A value, C value, you should find now B value. To find B value, I can substitute any number I can substitute in the equation 1 except 0 and minus 2. Except 0 and minus 2, I can substitute any number to find that, to simplify. Any number I can substitute. So you can substitute any number here, then you will get this value. Put x equal to 1, because we didn't put x equal to 1 in 1. Put x equal to 1 in 1. If we substitute put x equal to 1 in 1, you can see, you can consider x equal to 1 in 1. If we consider x equal to 1, left hand side it becomes 1 square, 1 plus 1 plus 1, 3 it comes, right? If we substitute, right, it's a into x square plus 1. A into x square plus 1 means it comes 2a, and you are substituting, we have bx plus c into x plus 2. There it comes 3b plus 3c. It comes 3b plus 3c. 3b plus 3c. This is 3 equal to, we know a value and c value. So a value we know that 3 by 5. This will be 6 by 5. 3b. And c value I can write 1 by 5. I can simplify, right? This is 3c. 3 by 5 I can write. 6. This you can see, find b value now. Find, but you can write this is 3 equal to 6 by 5, 3 by 5, because this is 3 by 5. So this will be 9 by 5 plus 3b. Then I can write 3b equal to 3 minus 9 by 5. It will come 56 by 5. Then b is equal to 2 by 5. I can find the values like this. We got c equal to 1 by 5. C equal to 1 by 5. B is equal to 2 by 5. And a is equal to 3 by 5. A is equal to 3 by 5. After finding all the values, then I can write the given problem. Then I can write equation. Therefore, I can write x square plus x plus 1 by this one, x square plus 1, x square plus 1 into x plus 2. They get dx. This is given problem. I can write. So this expression I have written a by x plus 2. What is a value? 3 by 5. So 3 by 5 by x plus 2. X plus 2 plus bx plus c. 2 by 5 into x. C means 1 by 5 by x square plus 1. X square plus 1 whole dx. This is whole dx. You see, I can write now. After this, I can split clearly. I can split this. This I can write 3 by 5 1 by x plus 2 dx. You observe here. This is 2 by 5 means I get 1 by 5. 2x by x square plus 1 dx plus 1 by 5 1 by x square plus 1 dx with x square plus 1. Correct. This one. This is also x square plus 1. Now you can see here, I can write derivative of x plus 2 is 1. So 3 by 5 log mod x plus 2. Derivative of x square plus 1, 2x. 1 by 5 log mod x square plus 1. How means when the derivative of denominator is numerator, I can write log mod denominator. The next one. This is tan in 1 by 1 plus x square. Tan inverse x. 1 by 5 tan inverse x plus c. So like this we can solve this problem. Right. So this is also one of the important problem only in partial fractions. Right. Because you can do easily in partial fractions. That is one of the important problem. Now using definite integration, one more problem I want to explain. Indefinite integration. See that problem. After completing this problem, look into this problem here. Again, 2 more problems are there, 2-3 problems. With this I can complete this session. I can complete that. So now consider another important problem now. Right, consider another important problem. If we consider another important problem, right, you can consider another important problem. Right, you can see now. Integral 0 to 1. Integral 0 to 1. Cot inverse of integral 0 to 1. Cot inverse of 1 minus x plus x square dx. cot inverse of 1 minus x plus x square dx. This is important model. They given 0 to 1 cot inverse of 1 minus x square dx. 1 minus x square dx. Now you can see here, what I am saying here, if you observe this one, I can write this one, just observe this one. This is also most important one. Now when I am doing this one, cot 1 minus x plus x square dx, can I write this one as in terms of tan? Right? You can see that this is the given problem. I can write integral 0 to 1 tan inverse of 1 by 1 minus, take x common, x into 1 minus x I can write. Correct, x minus x plus x square. I can write x into 1 minus x. Because correct. I can write in the place of 1. I can, you can see sum of these two, x plus 1 minus x will be 1. So our convenient 0 to 1 tan inverse of, in the place of 1, x plus 1 minus x, x plus 1 minus x by 1 minus x into 1 minus x. It is like tan inverse of x plus y by 1 minus xy. So this problem is tan inverse of x plus y by 1 minus xy. That will be tan inverse x minus tan inverse y. It will become tan inverse x minus tan inverse of 1 minus x. Tan inverse of 1 minus x. It comes like this. Tan inverse of 1 minus x. So in this problem, I can apply again. You see this one, 0 to 1. This I can write 0 to 1 tan inverse x dx. 0 to 1 tan inverse of 1 minus x dx. Tan inverse of 1 minus x dx. For the second integral, replace x with 1 minus x. You apply the property P4. Apply the property P4. If you apply the property P4 here, you can see integral 0 to 1 tan inverse x dx. 0 to 1 tan inverse of 1 minus x. You apply this property P4. Replace x with 1 minus x. There is no change in the function, in the integral function. This will become integral 0 to 1 tan inverse x dx minus this one I can write 0 to 1 tan inverse, check this, 1 minus 1, this will be x only. I have written here, you can see one mistake you can observe here. Tan inverse x plus y by 1 minus xy. This is plus, by mistake I have written, because tan inverse of x plus 1 minus xy, tan inverse x plus tan inverse y. We should write plus there. Tan inverse x plus tan inverse y. You should write tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y. So now you can see here. That is the reason I can write here. This is plus, be careful. Tan inverse x plus 1 minus xy. Tan inverse x plus tan inverse of 1 minus x. Tan inverse x plus 0 to 1. By mistake I written minus, this should be plus. Be careful that formula. Now you will get now. This will become, I told here, plus tan inverse x. Both are same. Now I can write 2 into 0 to 1 tan inverse x dx. This will become 2 into 0 to 1 tan inverse x dx. Now you should apply integration by here, integration by parts to simplify this. So to use integration by parts, you can make it this function. You observe here 2 into 0 to 1. What I will do now, tan inverse x into 1 dx. You can consider this is first function, this is second function. First function, second function. Integration by parts, we know that first into second you can write first integral second, derivative of first integral of second whole integral. So if you do this 2 into, you can apply here tan inverse x into integral 1 dx. This one you can observe here. 2 into, this is equal to 2 into tan inverse x tan inverse x into integral 1 dx, integral 1 dx, correct? You will get like this, minus derivative of tan in d, you can derivative of first function tan inverse x 1 by 1 plus x square integral 1 dx whole dx. I can write the limits 0 to 1. For this one I can write limit 0 to 1. I can write limits 0 to 1. The limits I can write. This is 1 dx. Now you can write this one. 2 into 1 dx is x. X tan inverse x. Just you can observe here. This will be x tan inverse x. Limit 0 to 1. This will be 1 dx is x. X by 1 plus x square. Limit 0 to 1. X by 1 plus x square. The denominator you can write. This is x by 1 plus x square dx. Now see here, this one I can apply, this limit I can simplify 0 to 1, the limit 0 to 1. The derivative of 1 plus x square is 2x. So I can make it 1 by 2x. Because we know that integral f dash x by f of x dx, it will be log mod f of x. It will be log mod f of x. Log mod f of x plus c will be there. Like this it compares here. Since this is a different integral, plus c is not required here. Now you can see this one I can write. 2 into applying upper limit 1 into tan inverse 1. Tan inverse 1 minus 0 it comes. This one 1 by 2 0 to 1 2x by 1 plus x square dx. You can follow the right side formula dx, right? So if you follow right side formula, this is dx. Here I can write tan inverse 1, this value I can write pi by 4. 2 into I can write, this is pi by 4 minus 1 by 2, I can write log mod 1 plus x square, applying the limits 0 to 1. 0 to 1. Then you will get the final answer. See this one, pi by 2 minus 1 by 2, applying upper limit, it will be log 2 minus log 1. Because we know log 1 will be 0. 1 plus 0. Log 1 will be 0. Pi by 2 minus of log, you will get pi by 2. We can see this one when I have taken. But you can careful here when you are doing the problem here. Where you see, just you can observe here. The most important one sometime. This 2 is common for everything. This is 2 is common for everything. You can compare with this. This 2 is common for everything. You should be careful. See, I have written by mistake the bracket means I am considering only one part. So this is 2 is common for everything here. This is 2 is common for everything here. Right. When I am expanding 2 into, you will get 2 into 1 by, this is 2 common. I can write 2 into 1 by 2. 2 into 1 by 2. It comes 2 to get cancelled here. This 2 it won't come here, right? It will get pi by 2 minus log 2 minus log 1. Log 1 will be 0. Answer will be pi by 2 minus log 2. Since log 1 is 0, that will be your answer. Pi by 2 minus log 2. Pi by 2 minus log 2 it comes. Pi by 2 minus log 2. Correct. Pi by 2 minus log 2. Okay. Now the last problem I am going to explain. It takes only 2-3 minutes. It takes another Two problems are there. With this I can complete this topic. Just wait another 5 more minutes. I can complete the important two problems. The important two problems, it will be completed. The topic I am going to complete integration part. Tomorrow I can do application of integrals. So see this problem. Integral 0 to pi. Integral 0 to pi. X tan x. It takes only 2 minutes. X tan x by x tan x secant x cosecant x secant x cosecant x dx secant x cosecant x dx 0 to x tan x by secant x into cosecant x dx. So this is given problem. This can be written as, see if you observe, this is a simple problem. If you observe this one, you can write which is equal to 0 to pi tan is sin x by cos x x into, you write sin x by cos x by secant x 1 by cos x into 1 by sin x cosecant x. You write like this. This become 0 to pi. You can see here, I can write this one. Cos x I can eliminate here. X into, it will become sin square x. X sin square x, it comes x into sin square x. We got like this, right? X sin square x. Since x is there, I suggested you apply the property P4. Now you can consider let I is equal to. This is a given problem. Let I is equal to, you can consider. If you take I is equal to, then replace 0 to pi x with pi minus x sin pi minus x whole square dx. Applying, replace x with pi minus x. This is sin pi minus x, sin x only. Then sin square x it comes. I can expand 0 to pi minus x into sin square x. That will become sin square x. Now you can split this pi into, you can write this one 0 to pi into sin square x dx minus 0 to pi x sin square x dx. So that is given problem. I only write x sin square x dx. This is I. So we have left side I. Now I can write. So to simplify this problem, I can transfer this side I. This I equal to pi into 0 to pi. We have limits. We have 0 to pi. Again you can apply this one. I can simplify. 0 to pi means again apply property P4. Replace x with pi minus x. Same function it comes. Sin of pi minus x whole square. It's coming same function. If you replace it, correct, you will get the same function if you replace, right? You will get the same function. That means I can write here, I can do one thing here. This is first I will write sin square x dx minus I. Transfer this side, 2y is equal to. So this side you can transfer this side, 2y is equal to pi into 0 to pi sin square x dx. But we know that f of x, you can consider f of x is equal to sin square x. You get f of pi minus x. You consider f of pi minus x. Pi minus, this will be same thing, it comes sin of pi minus x whole square. It will be sin square x. It will be f of x. Because sin 180 minus x, sin x. So sin square is f of x. So by property, you know, property P6, I can write this property P6. I can write 2y is equal to pi into 2 into 0 to pi by 2 sin square x. Indefinitely sin square x dx, right? 0 to half of this pi sin square x dx. Correct. Now I can cancel this one. 2 I can eliminate this, right? Then I is equal to pi into. So you will get I is equal to, this is pi, you will get I is equal to pi into integral 0 to pi by 2 sin square s. Again if you want, I can apply, this is, we know I is equal to pi into. I can consider this is I1, I can solve that. Otherwise I can do one more way also. Sin square you can use 0 to pi by 2. Sin square x always 1 minus cos 2x pi 2. or using property also we can do. I have written 1 minus cos 2x by 2 dx. Either you can use property or you write sin square x is 1 minus cos 2x by 2. It will be pi by 2. So 0 to pi by 2 we can write 1 dx means x. Cos 2 integral cos 2x you will get sin 2x by 2. Apply the limits 0 to pi by 2. Apply the limit 0 to pi by 2. You can simplify. If I simplify pi by 2, upper limit pi by 2 minus sin pi, it comes 0. It comes, if we substitute lower limit 0, everything 0. So answer it comes only, you can see here, pi by 2 into pi by 2, pi square by 4. It comes answer will be pi square by 4. Pi square by 4. So almost I have taken more problem, 1 or 2 problems I will refer you, you can solve that. Almost I am going to stop the session now. The session just, I can give 2-3 problems, you can solve those. Along with this, you can solve the problems, few more problems you to give. You try to solve those problems. If you are not getting, you can ask me. Along with this, try to solve these problems. Try to solve these problems. You can write integral 3x minus 1 by x minus 1 into x minus 2 into x minus 3 dx. You can also solve this. You try to solve this. You can solve this problem. If you are not getting, please update me in the message, like in the comment box. I can explain again if it is required. Another one, integral root of 1 minus root x by 1 plus root x dx. Root x dx. Here hint I will give. I can consider hint. You can, to solve this problem, you can consider the hint is root x is equal to cos theta. You take root x is equal to cos theta, you can solve this problem. Next, the another problem I will tell you this. Try to solve these problems because I don't have time to explain to you. If it is required, please comment box you write. I can, if you want, I can explain in the next class also if you want. Another one, integral sin inverse root x minus cos inverse root x by sin inverse root x plus cos inverse root x dx. This also. And the last problem, because these are my expected questions, you can try to do this. The last problem, integral pi by 6 to pi by 3, integral pi by 6 to pi by 3. See this one, this is the last problem. Integral pi by 6 to pi by 3, pi by 6 to pi by 3, 1 by 1 plus root to tan x. Root to tan x dx. Sometimes some people they may ask, instead of tan x they may give cot x. So these are my expected questions. Almost I have completed my problems. So because of the time being I am not able to explain this. Suppose you are expecting to solve any one of the problem, in the comment box send me that message in this video. Definitely I can explain to you. So in this video only, in this session only, in the comment box send me your query. You can send me the comment box which question is required. I can explain you in the next class, definitely, no doubt in that. I will help you, I will explain the questions in the next class. Thank you so much. See you in the next class. I'll see you in the next class. See, try to solve those problems. If you are expecting any problem to solve, let me know in the comment box. You can discuss with that. I can explain to you if it is required in the next class. Bye bye. Good night. Right. Done. Okay.